Good afternoon, everyone. This is Dr. Barbour. This is our second lecture. We'll be covering Chapter 2, the Research Enterprise in Psychology. We'll review experimental research. We'll also look at descriptive and correlational research as it pertains to answering research questions that we have about society, about behaviors and human behaviors in society. And so we'll talk about a whole host of different techniques, different research methods, and then we'll end on the ethics of research and psychology, and how we use ethics to make sure that everyone is doing uh, what we must do for society and protecting human beings and the animals that we research and study. Okay, let me get my pointer out. All right. So questions, questions, questions. That is the name of the game. As we talk about psychology, why were we founded? Right? Psychology was essentially founded to understand the human experience, to understand how our environment, how other people, and how we perceive and feel and experience the world. Right. So here are some questions that some have asked. Does sleeping less than 7 hours a day reduce how long you live? Right? How do we figure that out? Right? Do violent video games make people more aggressive? Can you make better decisions by not deliberating about them? Do men tend to overestimate women's interest in sexual liaisons? And does IQ or do IQ scores predict how long people will live? So these are questions that we ask. And so how do we find the answer to these questions? One of the reasons and one of the ways we do find the answer to these questions is by the research enterprise, by the scientific method. We'll talk about the scientific approach, the scientific method. It has 5 steps, and using those 5 steps, we use those 5 steps to answer the question. And investigating these types of questions is what psychology is all about. Um, as a psychologist and my colleagues, we're committed to addressing questions about the behavior through this formal, systematic approach, very empirical. We want it to be extremely objective so that we can, again, draw conclusions and draw um, uh, generalizations to the general public, right? That is the whole goal of why psychologists are who they are. We want to improve the lived outcomes for people in society and around the world. Okay, so we're going to hop right in. There are 5 units, so we'll hop right in and get to it. Let me set my clock so I don't go over time. Let's do this really quickly. But as we begin to talk about the psychological approach and the scientific approach, we have to dive into the steps. And the scientific approach is like it's like a recipe. It's a recipe for us. It's what we use to again create and design quality research. That is one of the main reasons why we're here, right? We're here to again have objective research and answer the questions that some of the answers to some of those questions that I just asked, right? That's the key. So when we go to talking about introducing the scientific method, the scientific enterprise, there are several different components to it, right? One of the biggest things that we do is we have to find a way to measure and create measurement techniques, right? If I wanted to assess the height of everyone in our class, I would measure us on maybe have a tape measure to measure everyone's height in the class. That's a way of measurement. If I wanted to determine, the enthusiasm for individuals in the class, then perhaps I could give you all a survey or just ask you a question right off and just ask on a scale from zero to 10, 0 being no enthusiasm, 10 being the highest amount of enthusiasm. Where do you sit on this particular scale? I can ask you that. That's a way of measurement. But again, I'm trying to describe the behavior extremely clearly and precisely based on a measurement tool or technique. Okay. In the scientific enterprise, in the scientific approach, the hypothesis is extremely important. So we have a question, a research question, that the research question about, uh, does violent video games influence the aggression in people, right? That is a research question. Then the hypothesis would say, I'm going to do we call an educated guess and say the increase in the amount of violent video games that people watch or play, it will increase the aggression score by some amount, right? That's that's what we're wanting to find out, right? Is there a relationship between two or more variables? Is there a relationship between aggression and violent video games or not, right? The variables are any condition, any measurable condition or event, any characteristic or behavior that we can control and observe in a study, right? So in our case, I can again look at how many violent video games or violent movies individuals watch. That's one variable. And then also measure their aggression. That's another variable. But then how do I measure that? I have to figure out how I want to measure aggression. When we talk about application and control, so the theory that we talk about is kind of a system of those interrelated ideas, and it's used to explain a set of observations that we see. When we first started off in psychology, we essentially were developing theories, right? Charles Darwin has a theory of evolution, and the theory of evolution says that survival of the fittest is king, right? Those who are the strongest, those who are the smartest, they survive because their characteristics, their traits, their dominance allows them to conquer and survive. And those who are weaker get dominated, and those characteristics oftentimes die off, right? So again, we understand with what we're doing that again that is a big piece, right? Then you have what we call an operational definition, right? An operational definition is a definition that describes the action. I ask all the time, how do you define love, right? How do you define love, or how do you determine if someone is motivated? How do you define motivation? Now, everyone has a different definition of what motivation is, or what love may be. Love is an action. Love is a feeling. Love is expressed through words. But again, that idea of love is really, really important because, again, that's our operational definition of love. It is a way that we can measure it. We can look at someone's actions. We can look at the way someone speaks to us to determine if they love us or not. And that's how we measure it. And we can control for different variables to be able to do it. Okay. But there are 5 steps to the scientific investigation. You have formulating a testable hypothesis. Again, that hypothesis is extremely important. We want to give and formulate an educated guess of what we see and what might happen with the theory, right? So we have to translate that theory into an idea, and then we can test it. The second thing that we do in scientific investigation is select the research method and the design, right? Do I want to uh, do a case study, right? Do I want to have a naturalistic observation? Do I have an opportunity to do an experiment? I have some control in doing an experiment. But again, doing the and choosing your method is largely dependent upon the nature of your question, your research question, and your hypothesis. But again, you have to determine, okay, who my participants going to be? If I'm going to do a case study, who is the case study going to be on? Is it going to be on a single individual person? Is it going to be on a class? Is it going to be on a business? If I do a survey, who am I surveying? Who are my participants? Who will be participating in that survey? Will it be students in an HBCU, or will it be employees at Toyota manufacturing company? That's what we have to figure out. Okay. Third step is collecting data, right? You want to be able to collect data. Data collection techniques vary based on, again, what you are wanting to study. Here are some examples. You have what we call direct observation, where you're looking to directly observe behaviors of individuals. You have a questionnaire, surveys, interviews, psychological tests. Um, a psychological test that's really, really popular now is the IQ test. You have IQ testing. You can test for aptitude and introversion, extroversion, um, you name it. Any of those non-observable behaviors, we can again assess it through psychological testing, physiological recording, and the examination of archival records. So again, these are examples of different data collection techniques. You then, once you collect your data, you analyze the data and draw conclusions from the data, right? So you make the observations, you convert whatever the numbers are into data that you can use. You analyze it through statistical methods or through thematic analysis or whatever it is, whatever the data is. It could be numerical, it could be through something that's really more qualitative. And so you'll use different techniques to evaluate it. And then again, statistics, again, that are helping you to assess or draw conclusions. Again, here are some examples here. Here you have t-tests, ANOVAs, correlations, and regression. All of these are different methods to analyze and draw conclusions from your data. And then here are some of those key data collection techniques that we described in the previous slide. And again, you can look here to see kind of a description of those. Okay, and then the last and final step is report your findings. Reporting our findings is extremely important, especially for researchers, because in order for a theory to be solidified as something that is right, I'm not going to say right, something that is observed on a common basis, then we must be able to replicate what we see, right? So if I'm reading a research article on aggression in young boys and their consumption of violent video games, then I read the results of one study and I want to confirm if that is true or not, right? So I then replicate that study to determine if what in fact was reported in the previous study was true. And then I report my results and I confirm that the violent video games have an influence on the aggression in people. Okay, but again, one way that those reportings are given is through journal articles, right? We'll walk through a couple of journal articles. I want to give you an opportunity to learn about how to read through a journal article. You're going to have to critique one, right? So I want you to know what a journal article is, how we use it, and again, those different sections that you need to be mindful of as you critique it. Okay, some advantages to the scientific approach, right? Clarity and precision, right? When we're talking about the scientific approach, it requires that people are really specific as to exactly what they're talking about when they formulate the hypothesis, right? You don't want any question or any hypothesis that is extremely vague. I need you to be as specific as possible, right? If I'm looking at the aggression in boys and violent video games, I need to specify, violent video games, boys, and then I need to specify the age group, right? Am I just looking at adolescents? Am I looking at adults? Am I looking at young children? So we need to specify, be very specific in that hypothesis. The second thing is we're really relative intolerance to error, right? We demand as scientists that the data be and everything be extremely objective, right? We need thorough documentation before we can accept any ideas. I fact check almost everything. I'm a skeptic by nature, right? If someone tells me something, tells me a fact or a truth, and I'm not all that familiar with it, I will go and do my research on it to confirm and accept the idea. I have to be able to confirm it. I need documentation before I can. I have to fact check it, right? Research methods is the second thing. The differing approaches that we use to answer questions through observation, through measurement, through manipulation, and the control of variables in our empirical studies, that gives us an opportunity to provide really robust answers to questions, right? If I can ask you about motivation and I can measure you through survey questionnaire, through an interview, and then I can also observe you and see other indications of high motivation, then I'm able to, again, understand what motivation really is because I'm able to measure it and assess it in different ways, using different methods. Okay. So again, what is the first step of the scientific method? Okay. You can pause it, but if we go back, number one, you have to formulate the hypothesis. You have to formulate the hypothesis. That is the number one step in the scientific investigation. Again, translating the theory uh, or an intuitive idea into a testable hypothesis. Okay. Now let's move on to how. So we talked about the recipe, right? We talked about the recipe. Now we're going to talk about the ingredients that go into the recipe. Some of these ingredients are going to include what we call experimental research. When we're looking for the cause and effect of two particular variables or variables, we use experimental research. Okay? Experimental research is extremely important. It's almost considered the gold standard when we're looking for cause and effect because we're able to control different variables in a more controlled setting. Okay. When we refer to experiments, right, they are used more than any other research method. In this method, again, you are able to manipulate variables under carefully controlled conditions. For those who have taken chemistry before, right, if we're looking at the chemical reaction in various substances, right? Maybe I have three beakers with the same substance, and I want to see reactions of different substances. And I mix in, say, baking soda in one. I mix in salt in the second beaker and sugar in the third beaker, right? I'm manipulating the different variables. There are three beakers with, let's say, vinegar in them, right? And so I want to see what interaction happens when I mix certain liquids, right? That's an experiment. All of the beakers have the same amount of vinegar in them, and I'm putting the same amount of baking soda, baking soda, salt, or sugar in each of the beakers to see what the interaction is, right? Then I want to see if there's an observed change, right? Does the baking soda have any chemical reaction? Does the salt? Does the sugar? And we're able to again see that. We were able to observe that, right? And then that gives me and allows for the detection of what we call cause and effect. If I pour in the baking soda in the vinegar mixture and it starts to fizz, I see the cause, and that's the interaction, right? By pouring baking soda in vinegar, there's a reaction, right? I don't see an interaction with the salt. I don't see an interaction with the sugar, but I do see a cause and effect of pouring baking soda in vinegar if there seems to be a chemical reaction, right? So again, experiments are extremely controlled. Usually they're done where I can kind of control for variables and eliminate some of the outside variables that might influence um, the data we collect, the results. Okay. In experimental research, okay, the purpose of an experiment again is to find out the cause and effect. And we want to see if there's a change in one variable and if that change causes the change in another variable. Okay. And again, that's cause and effect. So if I'm looking at ice cream consumption, and this is a correlational research, but I'm looking at ice cream consumption and the temperature outside, right? I can see that as I increase the temperature outside, ice cream consumption increases, ice cream sales goes up, right? Now, there is a cause, there may be an effect, but, and as we'll see in the next unit, I can't say that that's a true cause and effect because there might be some other variables that influence ice cream sales in a different way. It might not just be, some of the variation might be contributed to the temperature, but some people just love ice cream. Um, I eat ice cream year round, and so hey, some people just consume ice cream either way, right? But there are two variables that we are controlling for in the experiment. Well, there's two variables that we use in experiments. We have an independent variable and we have a dependent variable. The independent variable is that condition or that event that an experimenter varies in order to see its impact on another variable. That other variable is what we call the dependent variable, right? So as I change the one variable, right, I want to see if changing one variable then changes the dependent variable. And the dependent variable is dependent upon the change that I see of the manipulation in the independent variable, right? So again, independent variable is affecting and changing and has an impact on the dependent variable. So we want to measure the dependent variable to see if there's any changes, right? So here's an experiment, right? I want to see if I have a math intervention, right? I work in a low income elementary school, and the math level in the school is really, really low. So what I want to do is I want to see if my math intervention can improve math scores throughout the school year. I have two groups. I have what we call an experimental group, I have a control group. My experimental group, they get the intervention, right? They go through this 8-week program, and it's really, really intensive. And then my control group, they just go about their lives as normal. And then at the end of the 8 weeks, they're measured on a math assessment, right? And now I want to see if my math scores in the experimental group are any different than the math scores or the average math scores in the control group. And if they are, if the math scores in the experimental group are extremely or significantly higher than those in the control group, I know that uh, my intervention, my 8-week intervention, had an effect. That's what I desire to see happen. Okay, so here are some examples. Okay, test your knowledge. It says a researcher is interested in how heart rate and blood pressure are affected by viewing a violent film sequence, as opposed to a non-violent film sequence. Right? Identify the independent variable and the dependent variable. And I'll give you a few seconds. Pause the video if necessary. If we're looking at the independent variable, again, we're looking for the variable that is going to be manipulated, that's going to be controlled. And then the dependent variable is the variable that we're measuring, right? What are we measuring? In this example, we are, again, we're looking at viewing a violent film sequence as opposed to a non-violent film sequence. Now, we can manipulate that, right? For our participants, we can determine who sees the violent film sequence and who sees the non-violent film sequence. Or we have one individual view a violent film sequence, and then we have them view a non-violent film sequence, and we measure their heart rate and their blood pressure to see if there's any change in those two physiological measures, right? So in this example, film violence, presence versus absence is the independent variable, and the dependent variable is heart rate and blood pressure, because heart rate and blood pressure is dependent upon my watching a violent film sequence or a non-violent film sequence. The second example, it says a social psychologist investigates the impact of group size on subjects, right? So when we talk about conformity in response to group pressure, right? So a social psychologist investigates the impact of group size on a subject's conformity in response to group pressure, right? So again, what am I going to be able to manipulate? Right? The independent variable is what I'm able to manipulate. The dependent variable is what I'm going to be measuring. In this example, the thing that I'm able to manipulate in this example is the group size. I can have a group size of 1, or a group size of 5, or a group size of 10, or 15, or 20. And then I want to measure the dependent variable, the group pressure. How is group pressure measured? We have no clue how we measure it, but we do know that it is a dependent variable, right? So we're measuring conformity. We're measuring conformity in, we talk about group pressure, right? So again, group size, large versus small, and then conformity. One other thing that we talk about with experimental research is the idea of experimental group versus a control group, right? The subjects in the experimental group, they receive the special treatment in regard to whatever the independent variable is, right? And the persons in the control group, they do not receive the special treatment given to the experimental group. So you have somebody that receives it, maybe they receive the secret drug or the special drug, and the control group does not, right? It is really, really crucial, and that's very, very important. That's why I put down here at the bottom that your experimental group and your control groups be very, very similar. Okay. When you have similarity in your two groups, and you give one group the intervention of the treatment and the other group not, you don't give them the treatment, then you're able to eliminate some of the other variables that we'll talk about, some of those extraneous variables that we talk about, those outside factors, right? If I know that everybody in my group is pretty similar, then I know that if there are changes in the experimental group, I know it's due to the actual drug, the actual independent variable. Okay. So extraneous variables. Extraneous variables is really just a key term for the outside variables or other variables that might influence the dependent variable, right? So we talked about aggression in young people and their viewing of violent video games, right? Or let's talk about the example with viewing a violent video sequence and viewing a non-violent video sequence, and then blood pressure and heart rate, right? So I might already have high blood pressure, right? So that might be an extraneous variable in the experiment because I already have high blood pressure, and viewing a violent video sequence versus a non-violent video sequence is not really going to make that big of a difference because I'm already very, very high video sequence. I mean, high blood pressure, right? So that's an extraneous variable. Or maybe I just had a big fight with my girlfriend, and now my heart rate, my blood pressure is already up through the roof, and I'm really, really worried about that, right? So again, those are some extraneous variables that might impact the results that we get. Here's an example. So it says, is memory capacity related to test performance? Some extraneous variables that might muddle or kind of influence test performance might be test taking time of day, right? So the earlier I take it, I'm not a morning person. I take a test earlier in the morning. I might not do that well on the test, right? Testing anxiety. Some individuals have testing anxiety, and that will influence the test performance. And then the last one is the level of stress. How stressed are you? If you're already stressed out, maybe you didn't get enough rest the night before, and you're stressed because you didn't get enough time to study, then that could also affect your test performance. And so memory capacity can influence test performance, but there are other variables that might also influence as well. So that could influence the results of the study. Okay? Confounding variables are very, very similar. Again, we talk about extraneous variables. Confounding variables are those variables that are kind of linked together, right? So it occurs when two variables are linked in a way that makes it difficult to sort out their specific effects, right? So it's very unanticipated though, right? So here are three variables, and they're all confounded, right? So we have ice cream consumption, we have sunburns, and we have temperature, right? Temperature goes up. What happens, right? We're in summertime now. It's 85 degrees outside. What happens? Temperature is increasing. More people are going to go to Sonic or Dairy Queen, go to the grocery store to get ice cream, consume ice cream, and more people are going to be outside on the lake, at the beach, and you're going to get more sunburns, right? All of these are confounded because they're all kind of related, right? So I can't really break up the specific effects because all of them are related, okay? The other gold standard to experimental research is random assignment. What random assignment does is it helps to control for those extraneous variables. This is a procedure where all subjects in a study have an equal chance of being assigned to any group or condition, right? So if I have an experimental group, I have a control group, and I want to make sure that everybody in the group has an equal chance of being assigned to either the experimental group or the control group. And if everyone has an equal chance, I know that there's some similarity in those groups. I know those groups are pretty equal, right? It's almost difficult to do this random assignment because you're not given a huge population to be able to do that. So sometimes you're unable to do it. And so this is what we call a true experiment, right? Where you can do a random assignment, you have a population of people, and you randomly assign individuals to experimental and the control group, right? But most times you're unable to do that, and you have to create your own groups. Okay. Variations in designing experiments. All right. So it is extremely advantageous, right, to use only one group of subjects who serve as their own control group. And this is what we call a repeated measures design. Right? A repeated measures design, you use one group of people, and you do it before and after, right? So say I want to measure a group of students um, on a particular therapy. How does therapy influence your uh, anxiety levels, right? Or let's say mindfulness, a mindfulness meditation technique, right? So I measure anxiety in students at the beginning, at, let's say week 0, right? Then I have a 4-week intervention where they come to me and learn about meditation and mindfulness for 2 weeks. Okay. At the end of the 2-week program, I then measure them again at week 3. Okay. On the anxiety measure, right? And I want to see if the intervention for week 1 and week 2 had any effect on anxiety for that same group of people, right? That is sometimes really, really important because maybe I don't have enough people, right, to have a control group and an experimental group, but I can use one group to do it. All right. It says the effects of the independent variables are evaluated by exposing a single group to an experimental condition and a control condition. Just like I told you, you know, you have you measure them at baseline, you have the intervention, and then you give them a test again to see if there's any change, right? But again, it's possible to manipulate more than one independent variable, and you can measure more than one dependent variable in a single experiment. So again, you can design your experiment in a number of ways. You could have 3 independent variables and 4 dependent variables, which is really, really complex, or you can have one dependent variable, one independent variable, and 8 dependent variables. It just depends on what you're studying, what your research question is, right? And there is interactions that are detected, right, between variables, right? So if I'm looking at, say, I'm looking at independent variables, I'm looking at introverted persons versus introverted persons, and then I'm also looking at male versus female, and I want to determine, I want to measure people on confidence, right? Those are 2 independent variables and 1 dependent variable, right? So again, I'm going to have a 2 by 2, right? And so I'm going to be able to study the interaction between being an introvert and a male and what that looks like as far as their confidence. Okay. Here are some advantages and disadvantages to experimental research. I'll let you read through this. I'm not going to read them to you. But again, one of the biggest advantages is we get to see the actual cause and effect of what we see happening in the research, right? We're able to see, okay, violent video games does in fact increase aggression if I am able to control for those extraneous variables, right? That is one of the biggest keys. One of the biggest disadvantages that we see to experimental research is oftentimes we're unable to really control what happens in the environment, and and a lot of variables that are in our natural world can't be manipulated the way we could do in a laboratory, right? So sometimes the results that we do get from experimental research seem to be kind of artificial, right? Because again, we cannot control for all the moving parts in an actual setting. So that is one downside to experimental research, but it does give us a basis for what the phenomena and the theory might be doing. All right. We'll skip over the discussion activity. Okay. Looking for links, right? Looking for links, looking for connections, essentially looking for a relationship, right? Looking for a relationship between variables. This is what we call correlational research or descriptive research, right? This is when we don't have the opportunity to really control for variables, right? We can't manipulate the variables using an independent variable and dependent variable. But what we can see is we can see 2 variables and how they operate naturally in the environment, right? We're able to do that, right? So what we're going to do, we're going to talk through some really important concepts and facts about correlational research, okay? So when we talk about the concept, right, correlational research exists when two variables are related to each other. That is what a correlation is. It's a relationship. How are two things related? Okay. How are two things related? It's like me being related to my mom, right? We're related, right, by some commonality, right? A positive correlation or a positive relationship, it occurs when two variables co-vary or change in the same direction. They occur and change in the same direction. And I'll give you some examples on the next slide. A negative correlation indicates that two variables co-vary in opposite directions. So that means one variable is increasing and one variable is decreasing. They're going in the different directions. The positive correlation, both of the variables are increasing in the same way. Point in case, if you have a high school GPA, your college GPA is usually higher, right? Or the higher your high school GPA, the greater the likelihood that you're going to graduate college, right? So higher high school GPAs, higher graduation rates for those particular students in college, right? Negative correlation. You have a large amount of absences, right? Have a large amount of absences in class, your exam scores are going to go down, right? So if you miss a lot of class, your exam scores are going to go down. If you attend class, right, they go up, right? But if you have absences, go up, exam scores go down, okay? The terms positive and negative, they only refer to the direction, right? And I'll show you an example in how the line and the examples meant how the direction looks. Either is it up and to the right or is it down and to the right? So we'll talk about those two things, okay? But it does not refer to strength, and we'll talk about strength here on the next couple slides, okay? So again, when two things are positively correlated, they increase or decrease together. So in our example here, we have high school GPA, college GPA, they're increasing in the same direction. So a high school GPA and a high college GPA, they increase in the same direction. If your GPA is lower in high school, then you're likely to have a lower GPA in college. Okay. And again, this is just an average of occurrence of what's happening in the natural world. There are some differences. There are some individuals who just don't do really well in high school. They have a lower high school GPA, but their college GPA is pretty good, right? So it's not that it happens all the time because everybody is. That's the key for psychological research is the individual differences in people. Everyone is unique, and nothing is set in stone. Nothing is absolutely true. Nothing is absolutely fact because there are variations based on the human experience, right? The only other subject matters like chemistry, physics, like gravity is going to be gravity. Mathematics, 2 + 2 is going to be 4, right? Um, Pythagorean theorem, like all of those things are, again, it's set in stone, okay? Negative relationships, again, absences class increase, your exam scores decrease, and vice versa, okay? So when we talk about the correlational method, here's what we look for, right? So here's a table, and we have students. We got 1, 2, 3, 4, 5, 6, 7, 8 students, and we're measuring them on two variables. We have the amount of time they spend on Facebook, and we'll say the amount of time they spend on Facebook is in hours, and their academic performance. This is their GPAs, right? So what we see is student A, they spend 4 hours on Facebook a day, and they have a 2.4 GPA, right? Person B, student B, they spend 2 hours on Facebook a day, and they have a 3.6 GPA, right? C, they spend 2 hours, they have a 3.2, so on and so forth. This individual doesn't have social media at all, doesn't get on Facebook at all, and they have a 3.8 GPA. So what you're seeing, right, is an indication that there is a relationship there, right? There's a relationship there. And we can see, looking at this, what we call a scatter plot, that there is a negative relationship. That means it goes down and to the right. That means as you increase your Facebook time, your academic performance decreases. And so that is an increase in one way, Facebook time, and then a decrease in academic performance. Again, negative correlation, right? It doesn't tell me anything about the strength, but it does tell me that there is a negative correlation. Okay. So the concept of correlation is, again, also when we talk about negative, positive, that is the direction, right? Are they increasing in the same direction, or are they increasing and decreasing in opposite directions, right? The strength that I talked about before is based on what we call the correlation coefficient. It is an index of the degree of the relationship between the two variables that we discussed, right? The correlation coefficient is a numerical index, and it ranges from -1 all the way to +1 and anything in between, right? +1 is a perfect positive correlation. That means they're 1-to-1. With one increase in one variable is increasing in the same amount in the second variable, right? That's a 1-to-1, same exact increase and decrease, right? A negative correlation is a perfect negative. And then 0, if something is 0, that means there's no correlation whatsoever, no relationship between the two variables. And that happens where two variables just aren't related whatsoever. And we'll talk about some examples about what that is. Correlation and prediction, right? It says as a correlation increases in strength, again, gets closer to -1 or +1, you're more able to predict the variable based on the knowledge of the other variable, right? So if, let's say, high school GPA and college GPA are, really highly correlated, that means I can almost predict your your college GPA based on your high school GPA, right? And that's what happens when admissions officers are looking at your scores, looking at your ACT score, looking at your GPA from high school. They're just looking at, okay, what is their high school GPA? I know that there's a positive correlation between high school GPA and college GPA. Okay, so I know that if they have a high school GPA, they're probably going to be pretty academically sound in college, right? So let's give them a chance to get into college, right? So again, we're able to predict when we know those relationships are a lot higher. Okay, one thing that is always mentioned in psychology or in correlational research is correlation is not equivalent to causation. And what this means is that just because two variables are related to one another does not necessarily mean that there is a cause and effect from one or the other, right? And I'll show you next what that means. Okay. Here is, again, positive correlation. The correlation coefficient is indicated by the symbol R. So R equals 0.4, R equals 0, R equals -0.4, right? So we see a positive correlation here. It's going up and to the right there. When there's no correlation whatsoever, you see no trend in the dots, right? Also look at how spread out the dots are, right? The closer and the more clustered the dots are together, the higher the correlation, right? The higher the correlation. So if all my dots fell on this line, that would be a +1 correlation because every dot falls on this line, right? So this is an indication of, again, a perfect positive correlation. This is an indication of no correlation whatsoever. And this line right here indicates a perfect negative correlation. And you see all the dots around it indicate that they are away from that correlation. And again, it's a negative correlation down the So we talked about causation, right? Causation is, we talked about cause and effect in the experimental research. It's almost impossible to do cause and effect with correlational research because we cannot control and manipulate the variables in the experiment, right? So we can demonstrate there is a relationship between two variables, right? Almost every variable has some type of relationship or not, right? And we can see that if we have two variables and we want to run a correlation on them, we can see that, right? But the correlation coefficient and the strength of it does not provide an explanation for the relationship. It doesn't explain like why those two things are related, right? So I know that they are related, but it doesn't explain how. And that if you can't explain again why they're related, then you can't really show causation because again there might be other factors that influence and contribute to the causation, right? The causation of it. So again, most importantly, most importantly, it does not demonstrate a cause and effect relationship between the two variables, right? So even though, again, we do see a relationship, positive or negative, it does not show cause and effect. Here is what we call a spurious correlation between two variables, right? We have the number of people, or we have the per capita cheese consumption, very, very random variable, right? And we have number of people who died by becoming tangled in their bed sheets. I can't imagine that was a thing. That is absolutely wild. And it says that bed sheet tanglings from 2000, you had like what almost 400 deaths, right? You had 600 deaths in 2005. You had 800 deaths in 2009. I didn't even know that was a thing, right? But there is a correlation, right? You see these lines, these two lines, they're trending in the same direction. And here's the correlation. The correlation is 0.947091. That is a very, very high correlation. That means these things are related, highly, highly related. But we can't say that this is causing cheese consumption is causing people to be tangled up in their bed sheets. We can't say that, right? So again, there's no cause and effect. And that's why you can't do cause and effect correlation because there are so many other variables, right? These are totally unrelated incidences, right? But again, they are related just based on the nature of the variable. But again, this is called a spurious correlation. Again, they are not related whatsoever. Okay? So that is correlation. Okay. What about naturalistic observation? This is another technique, another descriptive research, right? Naturalistic observation is a descriptive research method where we engage in kind of this careful observation of people and behavior without intervening directly with the subjects, right? So if I wanted to look at, let's say I wanted to look at altruism or helping behavior in the mall, right? And I'm just sitting on a bench and I'm just watching people walk by, watching people walk by. They don't know I'm doing anything. I got my little, I'm reading a newspaper, but I got a notepad and I'm just observing and I'm notating things. I'm looking at helping behavior. Or there's a study that was done with people who needed to wash their hands, right? So washing your hands and in the bathroom and how long people were washing their hands. So we had somebody in the bathroom and they act like they're using the restroom, but what they were doing was they were waiting to see someone wash their hands and then see how long they washed their hands for, right? And they didn't intervene. They just timed when they turned the water on, how long they washed, and they took the time when um, they stopped the water, right? But again, this is in less artificial conditions, right? So we have to study behavior sometimes in less artificial conditions, and this is the way we do it, right? One thing that happens though, what happens if the subject knows they're being watched, right? This is what we call reactivity, right? When a subject knows that they're being watched and that they're in the presence of somebody watching them, they alter and oftentimes alter their behavior, right? That's why when we're looking at reality TV, some of that stuff is scripted. Some of that stuff, they know they're on TV. They just putting on. They putting on for the show. I don't know if any of y'all watch Love and Marriage Huntsville. Love and Marriage Huntsville. But again, a lot of that is scripted. A lot of that is they know they're on TV and they're doing certain things just based on them knowing and knowing that they're on TV, right? We have to be mindful of that, right? But again, it's really, really difficult to translate naturalistic observations into numerical data. And with that being said, we can't really do any statistical analysis with it, right? All we can do is we can mention what we observe. The only thing that we can do is maybe quantify maybe incidences of a particular behavior. But again, even with that, it's really subjective because aggression to me might look different in aggression for you, right? So you can observe what someone is doing, but you're less able to tell why people are doing what they're doing, unless you're able to ask them why they're doing what they're doing. And that might be an additional piece to the survey or to the research. Case studies, right? An in-depth investigation of an individual subject, right? Talking about interviews, direct observation. We're talking about the examination of records, psychological testing. All of those things are case studies, right? We're looking at a particular, and one maybe a single person or investigating a particular phenomenon, but we're doing it in a very detailed deep dive. And again, case studies are usually done on people, places, or maybe a company, or organization, or thing, right? So again, they are very well suited for individuals, right? So if someone has a psychological disorder, and I want to study the psychological disorder in depth, right? Maybe somebody like Michael Jackson. I want to study them in depth, and I want to understand how they move, what they're doing, right? I study their life, I study them, I study their history, and I want to understand why they do what they do, right? It's really highly subjective because, again, you're focusing selectively on information that fits expectations oftentimes. And usually it kind of reflects a theoretical slant, but again, it's very, very subjective. It is really relatively easy for investigators to see what they expect to see in the case study research because you're spending so much time with whatever the subject is, and it makes it easier for you to see what you want to see. And that creates bias sometimes in the research. Okay. Here's a famous case study, Phineas Gage, referred to as the man who began neuroscience. So what was happening in his situation, he was an individual who used to work at the railroad, and there was an iron rod that was driven through his skull, right? He was packing down some dynamite underneath the railroad track, and he hit the dynamite at just the right speed, and the explosion sent the iron rod through his skull, and the iron rod ended up landing about 30 feet from him, right? The miraculous thing was he did not lose consciousness, and he was still alive, right? He was speaking, right? But then they rushed him to the hospital, and then they looked at the damage that was done to his skull. It went right up through his face, right up through his skull, and it destroyed much of his frontal lobe, right? That accident and the experiences that happened after that is an example of the study, right? Example of a case study. They looked at his behavior, they looked at his personality to see if there were any differences being made, right? Was there any difference to his personality based on the damage that was done to his frontal lobe? Did his decision making was that affected at all, right? But again, you can't replicate that, right? You cannot replicate that situation at all, right? So again, that's a special case in the case study. This is one of the famous examples when we talk about case studies. Okay. One other thing that we do in descriptive research, kind of describing behavior, is questionnaires or what we call surveys and or interviews. Okay, we're using these techniques or these tools to, again, gain specific aspects about participants' background, about your attitudes, your beliefs, or your behavior, right? So we've all taken a survey. They've asked us about, our demographics, maybe where you're from, your birth date, your ethnicity, your education, your uh, parents' income, household income, or whatever. That's your background, right? Your attitudes. A lot of consumer organizations that sell things, they want product reviews, right? You buy something on Amazon and you see the reviews, and so they send out a brief survey to those who are consuming their product and they want to review. So they're looking at your attitudes. And then maybe what are your beliefs? Like, what do you believe about gun violence? Right? Let me send out a survey to students at university to see what their beliefs are about gun violence. Right? So again, all of these are really, really important. Right? So again, behaviors may be difficult to observe directly, but I can do them by asking you about your behaviors. You spend the most time with you, right? So I don't know, I don't know how much alcohol you consume, or do you smoke marijuana? I don't know those things, right? But you could tell me, right? Because I don't know, but you could tell me what your behaviors are, and that again is one way that we use interviews and questionnaires to do that, right? Again, we collect data, and it's very, very easy and convenient to collect data on a large sample of people. If I wanted to send a survey out to 200,000 people, I can do that and get a lot of data back based on the survey, right? It makes it very, very easy to do so. But one of the downsides, and what we'll talk about, is self-reported data, right? Which can distort the results, right? And we'll talk about some of those distortions in the next few slides. Also, when a survey's response rate declines, right? Say I sent out a survey to 100 people, right? 100 freshmen, and only 10 of those freshmen responded and submitted the survey, right? That's a small sample size, 10%, right? 10% samples, a 10% response rate, right? That doesn't give me much information at all, right? The higher my response rate, however, the better I'm able to then draw conclusions from the data that I collect, right? So you want to worry about the response rate. Some advantages to descriptive and correlational research. Again, you're able to explore questions that you could not examine with experimental procedures, right? You broaden your scope of the phenomena or the theory that psychologists want to study or can study. But one of the disadvantages is, again, you cannot demonstrate conclusively that there's a cause and effect. And one of the ways to get past this is to replicate over and over and over again to make sure that we're getting similar results with each study. And then again, with that replication, it allows us to then really play a big role in doing what we need to do. Okay, so it says risk research design would be best to study play behaviors among children. Okay, you can pause the video here, but if I was looking at play behaviors, right, and I didn't want to intrude or interact with the students, then you'd want to do a naturalistic observation, right? So again, I don't want to intervene, and this allows the individuals or the subjects to kind of play naturally, and without reactivity, I know that they're going to play like their natural self. Okay. All right, looking for flaws. With any research that's done, there are always going to be errors. There are always going to be some flaws that we have to be concerned with, and we'll talk about a few here shortly. Okay. So again, when we're talking about scientific research, right, it is more reliable than causal observations, right? Scientific research is, again, you can't just look and see what happens, right? Right? You can't just make an observation and, oh, it happened at one time, it's true. No. You want to do some scientific observation. You want to do some scientific research. You want to collect data on it, and then be able to draw conclusions about the causation, right? And again, not all published research is free of errors. There is always going to be error in measurement, error in reporting. There's always going to be errors, right? So when you're looking at research studies, you have to judge them with skepticism and be very, very critical. Again, when I read a research study, especially if it's not a peer-reviewed research study, something out of a journal or an academic or scholarly journal, maybe it's the New York Times article or an article I read out of Essence. I am very, very critical, right? I'm very, very skeptic when they don't show any citations to any research that's been done, right? Because they're just drawing conclusions based on their experiences, right? So some of the methodological problems that are included with some of the research is you got sampling bias. You oftentimes have placebo effects, distortions in self-report data. and experimenter bias, and we'll walk through these very, very quickly. Okay. So when we talk about sampling bias, you have two terms that you should know. You have a sample and you have a population. A sample is the collection of subjects selected for an observation in an empirical study, and the larger population or collection of people is the population. All right. So I'm drawing my sample from this population. Say I wanted to look at again, I use the population of college students here at Alabama University, right? About 6,000 students. We'll say 6,000, roughly 6,000 students, right? I take a sample of 5 students, and I want to understand their beliefs about gun violence on college campuses, right? That's a very, very small sample, right? So there's going to be a lot of error between the true beliefs of the entire population and the beliefs of those 5 people, right? So that's going to be error already, right? And when I have a small sample size, that is when I have sampling bias, because again, sampling bias occurs when the sample is not representative of the population from which it was drawn, right? So those 5 people, right? It's not going to give me a representation of the population. But what if I did 500 students, right? And they were all representative of the different sections or classifications of students. Then the idea or the beliefs that I receive, they might be representative to the population, and that would reduce the sampling bias. One of the big things that happens oftentimes, especially historically, was a lot of the researchers were doing research on um, um, cisgender white males and females, right? And so a lot of the research that was done, maybe in personality or motivation and other emotions, weren't done with other ethnic minority groups and people from other cultures, right? We are historically undersampled, right, by psychologists, and so it's really important if we really want to be representative and be able to generalize to the general population that we are able to, again, get samples that are and have and contain ethnic minorities and people from other cultures. That's really, really important. Okay, so we have to, again, review the composition of the sample before we concern ourselves with the results. So we look at the descriptives. If they say that people in, we'll just say people that watch TV, um, watch violent TV, are more susceptible to have dementia, right? Well, how do we know that? What people did they study, right? They could have studied individuals who are already um, predisposed to have memory problems, right? So we have to know what the population is. Okay. Placebo effect. Okay. Placebo is anything that resembles a drug, but has no pharmacological effect, right? So we know what a placebo is. Say I have my experimental group and my control group, and what I'm doing is I push to give this experimental group a diet drug, right? I want this drug or this pill helps with weight loss, right? And then I give the experimental group, again, these groups are similar. I give the experimental group a placebo, which is a sugar pill. They think they're taking a they think they're taking the weight loss drug, but they're just taking a placebo, right? And again, it is used because researchers know participants' expectations can influence their feelings. Right? People think that placebos really, really have no effect, but there is research that has been shown that placebos really, really have an effect. Your expectations play a bigger role than people would like to think, right? So again, the placebo effect leads you to experience some change, even though you received something that wasn't even effectual, right? So individuals who think they're drinking uh, an alcoholic beverage when actually it's just a virgin drink, usually they will show some signs of inebriation, just because they expect to feel inebriated with the drink, right? The placebo effect is really, really powerful, more powerful than, again, that we think. Distortions in self-report data. And this occurs when we're talking about the questionnaire and survey, right? So when we talk about social desirability, Social desirability is giving socially approved answers to questions about oneself when, again, you respond to a survey. People are less likely to uh, answer questions that are less desirable, make themselves look less desirable, right? So as research that was done in 2015, you're less likely to report that you smoke and drink more than you actually do. So you would actually report that you drink less, right, and smoke less. For me, when I was in college and my GPA wasn't all that high, and someone would have asked me my GPA, I would increase my GPA by a few points, right? Because it's more socially desirable to have higher GPAs, right? So that is a reason why we have that misunderstanding. And then you have respondents. Sometimes they just misunderstand the questionnaire items, right? Maybe the literacy level is a little lower, and so they don't understand the question, or the question is not worded correctly. Um, Sometimes the question order can shape responses, right? If you put all of the positive questions at the front and all the negative questions in the back, again, people just might mark, right? Memory errors. Obviously, people can't always remember things from maybe a year ago or 2 years ago, um, and so it undermines the accuracy, and that creates some error between what's true and what's not. Sometimes, depending on again the order, sometimes people tend to agree with nearly all the statements, or nearly tend to disagree with all the statements without even reading. Um, Many of you take the student evaluations, course evaluations, and many of y'all might, if you select strongly agree on one, you probably just select it all the way down, right? And then the last effect is what we call the halo effect. And this is very similar to the previous bullet point here. So the halo effect is when maybe you are, maybe you're really interested in a class, right? And you really enjoy the professor, right? And so during the course evaluation, you answer the question about, the professor was really kind and he did really well. And so you say strongly agree, right? And then since that kind of you really really enjoy the class and really really enjoy the professor, you think maybe the professor is really attractive, right? And so then you just mark strongly agree for everything, right? Even though the questions, the questions and the statements are all different. There should be some variability, but there's no variability because you have what we call the halo effect. It distorts the way you answer the questions, right? And it influences more of the specific ratings that should be and should vary, right? So again, halo effect is just like with individuals who look at someone who's attractive, right? They attribute someone being attractive to someone who might be a little more attractive, to who might be a little more intelligent, right? That's halo effect, right? You look at one characteristic of a person and then you attribute it to other characteristics. Okay. Experimental bias. Experimental bias is the phenomenon that occurs when a researcher's expectations influence the results that are obtained. And oftentimes it's inadvertent, right? Some researchers unintentionally influence the behavior of their subjects, right? So if I'm interviewing a subject and I'm asking them particular questions about their lived experiences, and I'm nodding and smiling, right? They might answer a question based on just my interaction with them, my vibe, right? Or maybe they say something that I really don't agree with, and so I frown, right? And that might change. They look at me, they change their whole mood, right? And they answer questions to then change the way I respond, right? And that just I'm influencing them, but I'm doing unintentionally just based on my facial expression, right? You also may influence both researchers' observations and their subject's behavior, right? So again, just having bias. Experimenter wants to see something happen, and just by their expectations, it affects their behavior, which then subsequently affects the behavior of the subjects. Okay. Um, One way to mitigate this is to have what we call a double-blind procedure, and this is a research strategy where neither the subjects nor the experimenter know which subjects are in the experimental group or the control group. All right. If I know the experimental group participants, then I might behave differently towards them versus those who are in the control group. Right. And so if I don't know, then my expectations across the board, my behavior may not change. Right. And so that's a way to again get rid of that bias. Okay? One other thing that we talk about is repetition, right? Replication is extremely important in the scientific approach in psychology. A lot of the previous theories that we talked about, the evolutionary theory we talked about with Charles Darwin, functionalism, psychoanalytic theory, um, all of those theories have been tested and continue to be tested even today, right? Research has been done on various topics over and over and over again. We know that the higher your high school GPA, the greater the likelihood that you're going to graduate college because we've been able to see the results over the course of time and it's been replicated over and over again, right? So we're able to identify and then remove anything that's inaccurate because we know that with great duplication and replication, we know that if one research study is getting one set of results, we should see similar results in another research study. Okay, we should. When we look at a number of studies together, that's what we consider our meta-analysis. And a meta-analysis is combining, again, we have 10 um, research studies that are studying high school GPA and the likelihood of graduating college, right? So I'm looking at a meta-analysis of um, all those research studies, and I then aggregate all of those statistical results. I combine them, and then I see some consistency in the variables across those, right? And that's the easiest way for me to understand it, right? To understand that, yeah, high school GPA does in fact influence graduation rates in college, okay? So it says Dr. Carlson is conducting a study where he combines the results of over 100 different studies on the topic of corporal punishment and development outcomes, okay? It says, what research design is this? Okay, we just mentioned it in the last slide. When you combine the results of over 100 different studies to look at the statistical significance, that is considered a meta-analysis, right? Okay, I'm going to try to zoom through this, running out of time. But when we talk about ethics, okay, when we talk about ethics, here's one particular study that I may not have time to go over now. I'll go over it in class. But again, the Tuskegee syphilis study, right? This was a point of concern when we talk about ethics and research and ethics, right? So the aim of the study was to record the natural history of syphilis in Black people, right? But what was done with these people was inhumane, right? They would tell the individuals that there are no proven treatments for syphilis at the time, and they took 600 men and women and enrolled them in the study, right? They injected infected individuals with syphilis who were part of the experimental group, and there are 201 individuals that were part of the control group. There were no proven treatments when the study began, but during the study, penicillin became the standard treatment for a disease in 1943, right? And even with that happening, they did not tell the participants that there was a treatment. There was a proven cure for the disease, and with that, people died because of that, right? People died because of the syphilis disease, and that is the ethics piece, right? You're doing harm to individuals, and that is very, very inhumane. And again, that was an ethic piece. We have to be really concerned about the people that we're studying. Okay. So why did it end? Again, somebody found out that they were doing this down in Tuskegee, and they made it upright. So between the start of the study in 1932 and the date when penicillin was determined, many people died. Dozens of men and their wives, children, and an untold number of others had been infected because, again, researchers were wanting to see the effect, the long-term effect, and in doing so, they were unethical in disclosing that they had found a cure. Okay, so again, questions for deception, right? They deceived them, right? They deceived them. The arguments against it, again, it equates to lying, right? It's immoral, right? It undermines the individual's trust in others. Many people don't like the doctor now because of what happened and how we were experimented on way back then, right? Researchers were doing all types of inhumane and unjust things to individuals of color. And again, it produces distress. The arguments for white lies are not likely harmful to the participants. Okay, it says empirical evidence does not support the notion that it undermines trust, right? But again, there are benefits, and sometimes that are worth the cost. But at what cost, right? If it's costing someone their life, then we have to be really, really concerned about that. And so again, with the Tuskegee syphilis study, again, that's what created a lot of the different ethical laws and guidelines that we have now. There were several different studies that created um, the inception and the emergence of all of these different ethical guidelines that we must follow now as researchers. And it's really, really important because, again, we want to benefit human life. We want to save human life, not hurt or harm anyone as a result of our research. Okay. In some instances, we use animals for research, right? Because again, there's some stuff that we cannot subject humans to, right? Now we can't put a human in a cage and observe them for 24/7, right? But we can't do that with an animal, right? So we don't want to violate rights and laws of humans, right? So we can use some animals. Animal rights activists, however, say that submitting animals to harm is wrong, right? Is wrong. And sometimes the results don't even apply to humans anyway, right? We'll talk about a few studies and how animal research was used in learning, in communication, um, in intelligence. Animals have been used to, again, talk about learning, how we learn. And again, we've been able to apply some of the techniques to humans without harming or using humans as subjects. Okay? But there are guidelines, there are ethical principles, right? You should be able to voluntarily withdraw at any time from a study. The researchers in the syphilis study didn't even allow for them to have that opportunity to do so, but they should have. That should have been an ethical principle um, that should have been done. Participants should not be subject to harmful or dangerous treatments. That's what they did in the syphilis study. It says participants should be debriefed as soon as possible if study requires deception, right? You should be able to, you should tell this, if you have to deceive a participant or a subject, you should tell them after the study, hey, I did this so that we could study this, but disclose everything and make sure that they are okay mentally and psychologically. And then participants' rights to privacy should never be compromised, right? The results of the study, if it's demographic information, it should never be shared. It should never be leaked. It should never be used in any other setting except for the purposes of research and the purposes that you say that you're going to use them for. Okay, and you're going to need consent. You always need consent when you're using human participants. The guidelines for research with animals, right? Again, harmful or painful procedures cannot be justified unless potential benefits of the research are substantial. You have to show that the benefits of the research that you're using to harm any subject, any animal, is substantial. So with a lot of cancer research and other research, some animals do die based on some of the drugs that they offer to the animals in a way to, again, cure certain human diseases, right? So again, we have to be mindful of that. Research animals are entitled to decent living conditions. And again, just like with anyone, you want everyone to be treated with, and everything to be treated with decency. Okay. So we're going to end there. Okay. We'll talk about the syphilis study in a little more detail because it's really important to the ethical guidelines that we have and principles that we have um, as psychologists and as scientists. We're going to end there. That is chapter 2, the scientific enterprise of psychology. You all have a great